So this is a pretty special video because it's the first long format video that I've put out since topping 5,000 subscribers. So I just wanted to take a moment to thank everyone that's been following me and sharing the videos to get the word out. The communities I've been working with over the past few years have been a real joy to support, and I'm excited to see what this year will bring to the channel. That being said, I've recently been in talks with Artillery about reviewing one of their products, and they were kind enough to send me this X3 Plus 3D printer to unbox, test, and review. The X3 Plus is a mid-sized bed slinger that offers a printing envelope of 300mm in X, 300mm in Y, and 400mm in Z. It includes a filament wiping system to clean off the little blob that tends to form on the nozzle during heating. It also includes a dual gear direct drive extruder, top-mounted LED light, dual vertical column support rods, dual Z-axis lead screws with dual motors. It offers a 4.3-inch touchscreen attached to a coiled cable for ease of operation. It uses a PEI sheet for the build surface. It has a 49-point bed leveling system along with leveling wheels to give you the best of both worlds for the optimal bed mesh. And it comes out of the box with a hot end capable of 300-degree printing. But that's just the marketing wank. Let's get this thing open and see what's really going on inside. But before I do that, I'd just like to give a quick shout out to the sponsor of this video, PCBWay, who offer a multitude of PCB-related products and services such as PCB prototyping, PCB assembly, SMD stencils, as well as CNC machining and 3D printing services. Check out their website at www.pcbway.com. So inside the box, there's the instruction manual, a little quick guide that basically shows you how to adjust your POM wheels and what to do when you initially level the machine. There's the typical bag of tools and goodies, all of the assembly screws and Allen keys, and a glue stick. Ugh. Here we've got the filament runout sensor that gets mounted to the top of the gantry, filament spool holder with a cam lock design, the 4.3-inch capacitive touchscreen, which actually uses an RJ11 phone cord, a la some other brands that we've seen before. Rail supports with what kind of looks like a carbon fiber design on them. I'm sure they're not really carbon fiber, but they do look kind of cool. And then we have the IEC connector. Here's the gantry that comes pre-assembled with the tool head. And as mentioned before, it's got dual Z-axis lead screws with dual motors, and it has the timing belt going across the two, which means that they're riding off of a parallel drive. And then finally there's the base of the machine with the removable PEI sheet on the heat bed. It's got some alignment pins on the ends here for when you put the plate back on. So I'm going to get this up on the table and start assembly. Okay, so all of the hardware is all in that bag, but I'm noticing that there's one baggie that is kind of missing some screws. So I'm going to have to reach out to Artillery and see what the story is with that. But there's a little piece of ribbon cable that's got to get connected somewhere. Here's the little box for the nozzle wiper, the assembly screws for the gantry, a little baggie with an additional nozzle, piece of PTFE tube, a USB stick with the SD card and some zip ties, USB-C cable, and again the filament runout sensors over there. So I'm going to assemble it to where it's assemblable to, and again find out what's going on with these, and we'll see where this goes. One thing about the screws is that the labeling is pretty good. It says M5x10 half round head for locking tie rods. So they do a pretty good job of labeling it. Still probably going to have to look through the manual just to see what is what, but chances are it should go together fairly easily. There is a little utility drawer here that I do like. Here you can see the belt adjustment is actually done via Allen key. So it flush mounts the tension screw, which is nice. I kind of like having the knob available, but it's nice because it's flush against that surface. And looking at the actual gantry itself, when I get it up on the table, we can see The gantry itself actually looks pretty cool because it's got a nice industrial kind of utilitarian look to it. So let me get the gantry up on the table and see what's what as far as assembly. First, put the gantry in place in the 2 notches on the bottom frame of the machine. Then, plug in the 3 connectors on the left rail and the single connector on the right. The ribbon cable is fed by a socket that attaches to a plug on the base, much like an old video game. The easiest way I found to put in the fasteners from the bottom was to hang the machine off of the table a little so I can get access to the 4 M5 screws that hold the gantry to the base. So now on these tension rods here, they don't come preset for the length, so you actually have to adjust this once you have it installed. So there's a couple of eyelets. There's an eyelet on each side, and then you lock it down with the nut once you get everything square. And that's what the labels are depicting on the bag here. You've got M5 by 16 and M5 by 10 for locking the tie rods to the bottom and the top. See, I didn't even have to read the instructions. Now, attach the spool holder to the top rail using the 2 M4 by 18 millimeter long screws by threading them into the tapped holes in the rail. Always make sure you read the instructions. The filament sensor screws into the hole on the right. Install the tie rods to the back using the provisions located up here and down on the frame. There's also a little baggie of washers to keep an eye out for because these go with the M5 screws that hold the tie rods in place. So just take a screw and a washer, place it inside the eyelet. The short ones go on the top and the long ones go on the bottom. Attach the screen bracket using the 2 screws inside of here. It's probably easiest to hang it over the edge of the table just a little bit so you can get your Allen wrench in there. And then just be careful because of this magnet, it kind of grabs your Allen key. And then I'll attach the screen. And that should be it. We're ready to power up and do some tests. Now, unfortunately, like I said, I don't have the screws to attach this, but that's not going to stop me from running my tests. I'm going to reach out to Artillery and I'm going to get those screws as quickly as they can send them. Okay, so I've got it all plugged in, so I'll do the honors. I'll turn it on, switch is on the back. Looking at the menu, we've got a couple different categories. We've got the tools category where you can set temperature, you can do a filament change, you can extrude filament at a certain speed. You can move your axes around. You can go into manual leveling, you go to auto leveling, you can set your Z offset, and you can do a nozzle clean, which will run a routine that uses the nozzle cleaner, but unfortunately I don't have that attached just yet. Under the print menu, if you have an SD card plugged in, you'll see your print files. Setting menu, we have fan setting, where we can turn on the hot end fan. There's linear advance turned on. There's shake compensation, which I assume is a form of input shaping or resonance tuning. There's factory reset, the motor off button to turn all the motors off, language selection, and then the about page. Under more, there's the LED control for the hot end LED. There's actually a tool head LED. There's actually tool head RGBW, so there's red, green, blue, and white. And then there's also the overhead light, which will turn on the LED strip on the top of the gantry. The sound button will disable the beep. And then the strong wind and low wind settings change the amount of power the fan has for the hot end at 100%. I mean, it's PWM controlled, so it'll throttle the speed up to 100%, but at 100% there is a noticeable difference between the strong setting and the low setting. And then under system, we have M119 and M503. And M503 we can use to query the settings that are currently active on the machine. The one thing that I did notice is that there is no bed level mesh page, which I kind of miss. I'm used to seeing a bed level mesh to kind of get a rough idea of where my bed settings are at, but it's not something that I can't live without. So the one thing that I have found is if you want to retain some semblance of online anonymity, it's kind of tough to do it with these larger printers because getting them in the frame vertically is tricky with a widescreen angle. But enough Google searches and you guys, I mean, half you know what I look like anyway, but it's just humor me. So I washed the PEI sheet with dish soap and water, and I did find that the granules on the PEI sheet are nice and thick. They're kind of reminiscent of the granules on the Ender 3 V3 SE plate that I got from UPI. They're a little more coarse, if you will, than my Elegoo Neptune PEI sheets, which happens to be a little bit finer. I'm not saying it's good, bad, or indifferent. I'm just pointing out the texture. It's got a nice feel to it. If I want to home the machine out, I just go to Tools, Move Axis, Home All. Now it uses an inductive sensor in the back right corner, and it's the exact same sensor. It's the Bowlin or whatever inductive sensor that the Elegoo Neptune series are using on the 3 Pros and the 4 series. And as I mentioned, I'll turn the lights off in the room, but you can see that there's a little LED coming out of the right side of the tool head, and that's to help illuminate your part during printing. And then the overhead lights cascade a little bit of light down onto it as well. So I do want to run a couple of tests. I want to see how quickly the hot end heats up, and I want to see how well the bed retains its listed temperature on the controller. So I'm going to start this up real fast. I'll go to temperature. I can set the hot end temperature and the bed temperature separate. It doesn't have a keypad when you press on either or, so you have to choose the temperature down here and then use the temp up and temp down that I've found anyway. So from here, I'll go temp up. Honestly, I could have done 100 degrees, but I went to 200 degrees here. And already I'm at 115, 130. So the hot end on this machine heats up extremely fast. It's already up to 185 degrees of 200. So it does take a couple seconds for it to stabilize, but it does get up to temperature incredibly fast. I would say that if that was 30 seconds, that's probably an overstatement. So I'll select the bed and I'll do the same thing. I'll go to 60 degrees on the bed. So it doesn't seem like the bed heats up as quickly as the hot end does, and that's kind of a bummer because this thing got extremely hot, extremely fast. So if this had an AC mains bed, or if it had a little bit more oomph to it with the voltage that it's running, it would have been nice to get everything up to speed, relatively similar time, but there's no way you're going to get 30 seconds out of this big plate. It just seems like right now it's at 39 degrees, and I've been waiting for this. Admittedly, I've been waiting for this for some time now. I've got my thermometer here, and once it gets up to 60 degrees, I'll be able to temp the surface, and I'll be able to see how accurate the bed temperature is. All right, we're up to stable temperature, 60 degrees. Now it should be 60 degrees. It says right on the display, 60 degrees. I'll hit this. Stay right about there. And you can see right here, 60.7. So with a little bit of PWM fluctuation or what have you, that's pretty good. So I am pretty happy with that. As far as the bed is concerned, if you look down the center, there's actually 2 metal standoffs that they're using to hold the center of the bed rigid. And then there's 6 leveling knobs on the outside, so you can basically adjust the flatness of the plate, not so much the level of the plate. I've got some filament loaded. I'm going to run a couple of tests. There's some test files on the SD card, but the stupid ass friggin' boats. So I may have to take one on the chin and just see if the times that they have listed on the SD card live up to expectation. Plus, I'd like to get an idea of how fast this thing actually moves. Another thing that I did want to point out on this machine is that it still uses homing switches, and it's got some interesting homing switches. The homing switches kind of almost give you the impression that this thing's got sensorless homing, but it doesn't. It's got these little spring-loaded plungers that attach to the switches. It's not directly hitting the would-be micro switch with the little metal arm. These are a little bit more upscale. But as I said earlier about the utilitarian kind of look, you could see that this ribbon cable runs nice and flush with this rail. The X-axis motor is actually turned in a way that it's sitting here as opposed to sticking out in any which way. So it kind of cleans this side up a little bit. You don't have that dingly wire loom in the back there. And then the X-axis rides on here, and you've got this ribbon cable here. And they actually included some extra ribbon cable in case something should happen to this. I did take the hot end cover off camera, and it's not very difficult. It's one screw, and then you have to pull out the ribbon cable here. So that's probably why they give you an extra one in case you damage this ribbon cable putting it back. But you pull this ribbon cable out, you slide this off, and then you can get into the internals. It's using what appears to be a single 5015 blower fan, but it's a special blower fan that has molded ducts already in it. And the ducts come out in the front and the back of the hot end. And quite honestly, it really puts out a lot of wind. So we'll see how it is during printing, but it does put out a lot of airflow. This machine comes with manual bed leveling, and it also comes with auto bed leveling by means of the inductive sensor on the back. Now, as I've said in the past, an inductive sensor is great for metallic surfaces. So if you're using this PEI sheet, or if you're using another type of coated spring steel, this will work fine. But don't ever try to put a piece of G10 or anything like that. Nothing non-metallic. If you use glass, if you use G10, you will have a problem with this machine because of the inductive sensor. But for now, if I wanted to double check the four corners and the center, what I could do is I can come in to manual level and go to center point. It brings the nozzle over to the center of the bed. I'll use my trusty sheet of paper. I'll put it underneath. And then once that's underneath, I can go back to the Z offset page. And then from here, I can set the Z offset. So I've got a pretty fair amount of drag there. I'll hit save, confirm, and then I can go back. I'll go to manual level again, and I'll double check. I'll go center point. And it's not bad, it seems to be repeating. Maybe bring it down a little bit more. Z offset. That feels about right. Save, confirm, back. And now from here I can go manual level, and I can go to all of my other points. I can go to my first point. Okay, got a little bit of drag underneath there. I'll go to my second point. Got about the same amount of drag there. Go to my third point. Now go to my fourth point. Okay, and that feels about right. So I'm going to go back, and then I'm going to go to auto level, and then the auto level procedure will begin. Once the auto level is done, hit save, and now we should be ready to go. Now the one thing that I'm not 100% keen on is the fact that I can't see the bed mesh being displayed on the controller. But I'm going to try out something and see if there's a way to see what I've got going on here. So let me hook up my laptop and I'll be right back. Okay, so I've now got the printer hooked up to my computer, and I'm running the Bed Leveler 5000 from S&M Makers. If you want to check them out, just check out snmmakers.com and you can download your copy of the Bed Leveler 5000, which is a manual leveling and mesh checking utility. There's also other utilities in the suite, such as the inspector G-code, which lets you parse G-code commands and see what the feedback is directly from the Marlin system. Plus there's the printer information wizard that lets you build your configuration, and that's what I did for the Bed Leveler 5000, is I built the Artillery Sidewinder X3 Plus configuration. I mapped all of the points for my bed level. I've got the 6 points that correlate to the position of the wheels, and then I've got the center, which is the center of the table, which correlates to the center position between the two rigid spacers. I'm using a new alpha version, if you will, that not only gives me the ability to check all of the points by clicking on these guys here in relation to the center, but also I have this probe all, which will check all of the points, and it will give me a feedback of all of the positions in relation to a reference point that I select over here. So if I select that my reference is center because that is where my rigid spacers are at, once it goes through all of the measurements, it will give me the feedback of where everything falls relative to the center position. If I output turns, it will go based on the thread pitch of the screws, which in most cases is going to be an M4 by, I believe M4 is 0.8. Don't count my word on that, but I believe the pitch on a metric 4mm is 0.8. If it's not, it's 0.7. But potato, potato, it'll just tell you how many turns or how much you have to turn your leveling screws to get to the desired location. To test out the manual level points, all I have to do is just click on a single point. It'll measure, and it'll tell me what my deviation is in relation to my center. So if I go to center and I tear that, I did this with the bed at temperature, and right now it's cold, which is why I'm getting a little bit of a deviation in the numbers, but the 0.03 millimeter, just to give you a reference if you are into imperial measurement, that is 0.001181 of an inch. So that's almost nothing. That is the thickness of a slice of paper slit down 4 times. Anyway, so if I wanted to run the routine for my actual bed mesh, I can go to the mesh page. It'll automatically determine what my mesh is based on the information it gets from Marlin. And not only do I have a bed mesh display here, but I've also got a 3D mesh, which will give me an output like this. It kind of gives me that clipper bed mesh wavy taco thing. So if I hit update mesh, it'll go in and it'll measure all of the points. So you can see right here all of the measurements that get taken when I run the update mesh. And like I said, I did this with the bed at temperature, and right now it's not showing the greatest result, but at temperature I was within 0.02, I believe, at all 4 corners. So this is a useful utility to use, not only to check the mesh, but again to visualize the wavy tortilla that I got here. And I can zoom into it, and I can actually go to each of the points and see what the readout is. But also, I can use this to repeatedly check each of these points and then get the numbers relative to my fixed location. And I don't have to continually use pieces of paper. I could just come over to this position here. I can see what the readout is. I can adjust the screw, hit it again. It'll manually probe it again, and it'll just tell me what the readout is for the difference between where I was and where I am. And then again, if I wanted to run all of the points, if I hit probe all, we can see right here what the output looks like. It shows me that my center is the fixed reference, and then from the fixed reference it tells me how much I have to turn each of the screws based on the point locations. So 0.5, 0.4, 0.6, 0.3, 0.1, and 0.2, where I have to actually turn the screws, how much I have to turn them in order to get a flat table. Now, again, I have done this at temperature, so I know that, relatively speaking, everything should be set fine. Oh, and just one more thing to keep in mind. The Bed Leveler 5000 is a utility for checking your mesh, but it does not update your mesh. So if you use this to measure your mesh, you can't save it. So you can see it, you can visualize it, you can read all the numbers, but if you want to save this mesh, you actually have to run the mesh in the machine again to make sure that the numbers get saved. So again, just keep that in mind. But without further ado, let's get into the test prints. Here you can see on this first test print how well the machine moves around. The acceleration values on the direction changes are nice and crisp, and the print speed is pretty high. The estimated time on the slice file was 17 minutes, but this one took about 21. I'm guessing the time spent heating up the bed is partially to blame for the discrepancy. So you can see on this one, it's actually pretty good. There's a little bit of sagging at the top of these little doorways here, and the bridging in the window has a hair of a sag in the center. But other than that, a couple of wisps of stringing. This print actually looks pretty good. Hey, look who decided to join the party. Okay, so not so great at the very top there. I had a failure at the spout, or whatever you want to call that. The rest of the print doesn't look bad. So let me try that again. So I had a couple of back-to-back print failures and decided to dig a little deeper into it. I washed the PEI sheet with some dish soap and water, and then noticed that the slice file's bed temperature would drop from 60 degrees in the beginning down to 45 degrees. I surmised that between that temperature drop and the cooling fan blowing on high speed that the part was doomed to fall off simply due to the settings of the factory file. So I slowed down the max fan speed and decided to slice and print out a few versions of the tried and true Voron cube. I think the boats are just aware of how much I hate them and decided to just not cooperate with me. So I printed out a total of 3 Voron cubes, and this is the first one. And you can see that without any kind of dialing in or tuning, that the surfaces look pretty good. The Y-axis, I'm not surprised that there's a little bit of ringing, only because my table hates me and I have to lag it to my wall still. And I know I always complain about that in every video, but that is just a matter of the truth. Top surface looks nice. Bottom surface is good. The bridging on the inside of the cube, kind of hard to see, but that's pretty good. Sizes are okay. The sizes are actually better than my other printers have been. You'll notice that here, there's a little bit of a loop-de-loo there, a little smiley face looking thing. And that's actually the Z-seam. So I may have to tune the, well, on this one it's going to be linear advance, but I'd have to tune the linear advance to dial out that seam a little bit better. But all in all, for the first run, it was pretty good. I also printed out a 20mm calibration cube, which also looks pretty good. A little bit of ringing in the Y-axis. All the surfaces have a little bit of, not ringing, but just what I typically expect from this filament. Just that kind of waviness that you get on the surface. Top surface looks good here. Bottom surface looks pretty good here. And then I wanted to get a bit of a time benchmark for what my slicer estimated the time would be versus what the Sidewinder X3 was actually giving me. So I printed out 2 more cubes. The first one I did, the estimated time was 43 minutes. And this is without, I did this without warming the bed up, so take that into consideration. This is without warming the bed up. The machine was already at temperature. So this is the result for the first cube using the same slicer profile that I use for all of my other machines. And I have it written down at the bottom here. The estimated time was 43 minutes, and this one was finished in 38. So 5 minutes faster than it thought it would be. And then I cranked up all the speeds that I could think of, and I got the estimated time down to 35 minutes, and I printed out this cube. There's a little bit more ringing on it, but ultimately I was able to produce this cube in 31 minutes. So it was 4 minutes faster than the estimated time from the slicer. So all in all, the results are pretty good. The prints that I was slicing myself were sticking to the machine way better than the you-know-who. So I'm going to chalk it up as just kind of crummy slicer settings, or maybe they just tune it for the filament that they provide. And the filament that I'm using is the red kilowatt like I've been using, and maybe the properties of it are a little bit different as far as bed adhesion. So my takeaways for the Artillery Sidewinder X3 Plus are that it's a good medium-sized 3D printer with plenty of capabilities, and a larger than normal capacity sets you up for larger prints in the future at a price point that is still within the realm of those just getting into the hobby but want something they can kind of grow into a little. The machine is easy to assemble, requiring only a few screws to put together. The hot end heats up insanely quickly, and the longer volcano-style nozzle ensure that you can print at higher speeds without bottlenecking at the filament flow rate. Much like a lot of the newer 3D printers coming out with the next-gen TJC or D1-style HMI screens, this printer does not offer Wi-Fi capabilities out of the box, but being that it's running a Marlin system, you can connect it to many of the available free utilities such as Repetier, Pronterface, and in my case the Bed Leveler 5000, which does also support Clipper, by the way. That being said, the source code has not been made public just yet for this printer, so making a Clipper binary for it is a little out of the question at the moment. But there is someone on Reddit who is working hard to get Clipper running on the X3 series of printers. The processor that it's running is an STM32F402, so building the binary for it should be a breeze. It's just the pinout they use on the processor to control everything that's in question. The Bed Leveler 5000 that I showcased in this video does a great job visualizing and seeing the numbers for each point of the bed mesh, which is one thing I did miss on the HMI for this machine. Another thing I did miss was the lack of a page to set E-steps, but I haven't dialed that in yet anyway, and it seems like the numbers provided work well right out of the box. It does come with linear advance and input shaping enabled, and they can easily be modified from the interface. As seen in the video, the X3 Plus may require some adjustments in the future, but I may work on that in another video to get a feel for the differences between tuning a Marlin system versus Clipper. So that'll about wrap it up for this one. If you liked the video, make sure you hit the thumbs up. If you're enjoying this type of content, please subscribe to the channel, unlike the 90% of my viewers who haven't. And if you know someone who would be interested in learning more about this stuff, share it with a friend because sharing is caring. Check out my affiliate links in the description down below at no additional cost to you. Just puts a little bit of catnip in my kitty and helps with my future channel endeavors. Thank you once again to Artillery for providing me with the Sidewinder X3 Plus for this review video, and my new channel sponsor, PCBWay. If you've got 10 seconds to kill, check out my website at www.theferralengineer.com. It's just a whole bunch more of the same stuff, but it justifies the $12 a year I spend on the URL. And finally, thank you to all my catnip contributors, both past, present, and future. Thank you for watching, and we'll see you again soon.